Let's go to page 231. This is section on reflection. Reflection means when you flip things over, like this one over here, when you flip it over. Now let me give you another example of this. Let's say if you have this piece over here, when you flip it over, it becomes like this. Okay, so that would be the reflection. So notice the orientation is opposite. Okay, so they're facing opposite. Whereas this would be a translation. Okay, so this would be translation. Whereas this would be a reflection. And this would be a rotation. Okay, for example, this would be like a rotation. So those are the different operations. So you can reflection. Now, when you're doing a reflection, you can reflect over a line like this over here. So it would be flip it over. Okay, so this line is called a line of symmetry. Okay, the line of symmetry. Now you also can reflect over a point. If you reflect over the point, you're actually doing a 180 degrees rotation. So again, when you reflect over a point, you just go and draw the line over and you just flip this point over this. So you flip the E over the point O, so become E prime. You reflect this over the point, become A prime. So when you have so this is a point of symmetry. So when you have point of symmetry, basically what you're doing, you're rotating 180 degrees. Okay. So again, remember that that's very important. So again, the point symmetry is same as rotating 180 degrees. Okay, and so again, the certain figure have a point of symmetry. Okay, so when you have a figure that when you reflect over a point and it map onto itself, would be example of a point. That means you have a point of symmetry. What I mean by that is that, for example, if you have a square, okay, so in this, if you have a square, then you have a point of symmetry over here, because this point, when you reflect over this, you end up with over here. This point, when you reflect over, you end up right over here. So the square has a point of symmetry. So same thing like circle. Okay, if you have a circle, okay, and you put over here, so any point when it reflect over the point, it will map onto itself. Okay. You also, for example, if you have a regular hexagon. Again, you have the point of symmetry because when you reflect over here, you end up right over here. So any point when you reflect, you will end up onto itself. Okay. Now, if you have a pentagon, if you have a regular pentagon, then you don't have a point of symmetry because if you reflect this over here, you're going to end up right over here. So it doesn't map onto itself. So this one does not have a point of symmetry. And also equal to the triangle. This one does not have a point of symmetry either because this one, when you reflect over, you will end up right over here, not over here. So this one is no. Okay. So there are certain shapes they have a point of symmetry, and the other regular shape they don't.